Right, hello everyone. So today I am going to be going over the software crisis that was Ariane 5 Flight 501. Alright, so kind of what I'm going to go over. First, a little bit of history, how it failed, why it failed, the significance of its failure, and some of the lessons learned. Alright, so a little bit of the history. Ariane 5 Flight 501 it was a rocket created by the European Space Agency, and they were working on this for a pretty long time. It's 10 years and $7 billion to produce this thing. And this rocket was going to be carrying 4 satellites to launch into the orbit, and they were going to be used to study the Earth's magnetosphere. And the launch took place June 4th, 1996. It didn't exactly work, though. 37 seconds into its launch, the rocket started to veer to the side, off course, and 39 seconds after the launch, Ariane 5's self-destruct mechanism explodes the rocket. So why did this happen? This was caused by a software error. The steering is controlled by a computer, and a bug caused the rocket to think that it needed to change course. So that's why at 37 seconds, it started to veer off to the side when it wasn't supposed to. And because the rocket veering to the side caused some aerodynamic forces that damaged the rocket, and it reached a point where it was so damaged, its self-destruct was triggered. So what exactly was this bug that ruined everything? Pretty much it was just it didn't properly handle converting. It wasn't protected from integer overflow. So a 64-bit number was trying to be converted to a 16-bit, and that caused an error. And the reason why this problem was in the code is they reused code from Ariane 4. And Ariane 4 didn't reach such high speeds at the initial trajectory. But Ariane 5 reached much higher speeds. And so that's why we're getting those bigger numbers. And because it couldn't properly handle the 64-bit, it made a large correction for altitude deviation that hadn't actually occurred. So the significance of this failure, it resulted in a loss of more than $370 million. And it's also known as one of the most infamous and expensive software bugs in history. So some of the lessons learned. The review process didn't fully analyze the limitations of the alignment software. The alignment software is where it didn't protect against the integer overflow. And so that was missed in the review process. Some of the tests performed didn't use Ariane 5's trajectory data. So because they were using Ariane 4 code in the alignment software, they hadn't actually tested that with Ariane 5's trajectory data. And when they did simulations of Ariane 5's launch, they used a simulated output of the alignment system instead of the actual system. If they had used the actual system, the error would have happened in their simulations and they would have detected that problem. But instead, for some reason, they decided to use a simulated output instead of just actually using the system. And so one of the important lessons learned is just there's really high risks with these complex computing systems. But something as simple as not being able to handle integer overflow can cause this rocket to explode. So yeah, thanks for listening.